at some trig identities, so proving them, and some different strategies we might be able to use. So like I said, it's very common for a teacher to tell a student, work on the left side and make sure that the final result is equal to the right side, or vice versa. Work on the right and make sure its final result is equal to the left. Okay, that can be nice if we kind of already know where our goal is, but it can be really hard to see where we're going to go, and you may get stuck halfway through something. So you had an idea of using your reciprocal identities. So we decided we were going to invert both of these, and we're going to use the reciprocal identity. We decided that we turn cotangent theta into 1 over cotangent. Nothing wrong with that. Okay, and we decided we would turn secant theta into 1 over cos theta. Okay, and I think you said you wanted to do the same over here also. Mm-hmm. Yeah, so you wanted to change cosecant into 1 over sine. Excellent. Okay, so I've gone about doing that, and right away, as you can tell, we clearly didn't work on just one side. Okay. Normally you would leave it like this, and then you would leave this as just cosecant. So because we didn't work on one side, maybe we have a teacher who's very particular about the method you use. There's nothing wrong with that. We're just going to do some reverse engineering a little later once we actually get our answer. So this is really good. If you remember your sine law, because these two sides are equal and they are fractions, I mean, like, let's actually equate these two. 1 times 1 is 1, so it's actually 1 over tan theta times cos theta, okay, is equal to, again, we worked on the right, sine theta, okay. We can invert everything, just like in sine law, like we talked about before. So I can flip everything. If I flip this side, as long as I flip this side, it works out great. So now we have tan theta times cos theta equals sine theta, okay? And hey, I just remembered something. If we look over here, quotient identities, tan is equal to sine over cos. Well, I can isolate for tan by bringing cos over and dividing by it. So we'll end up with tan theta is equal to sine theta over cos theta. Great. So we've gone about proving it. That's perfect, but particular, right? Very, very particular. In fact, maybe they tell you, I want you to only work on the left side of an equation. I don't know why, but maybe they do. Well, there's nothing wrong with this. We've worked on the left side. We got a whole bunch of info about the left. Now what we're going to do is slowly piece our right sides sequentially, so just one after the other. And move I don't know if I can draw that all in one step. Doesn't really work. And then the last one. So we're going to pull each of these steps and pull it to the left, and then just kind of erase what's on the right. And then it looks like you've only worked with one side of an equation. So let's ignore what was done on the right. If I had something, I could block this out. Okay, so let's ignore what's over here and just focus on what we did on the left. So we put the reciprocals in, we multiplied. We decided to flip this idea. Now, that is a tough concept here, to flip this one idea. We have to prove that when I do this, when I flip this, we have to keep in mind that we're flipping our other side here. So, give me a second. How can I hit a stumbling block here. This algebraic move where we went from this step to this step, you technically can't do unless you, I guess, unless you were to show that on the other side you're flipping it, okay? So we'll kind of actually almost have to like skip this move here. We won't be able to do that, so we'll have to work with this still. But we do know that according to this, tan times cos is equal to sine, and we can prove that over here and actually turn it into it. So I'll show you that. So we do have to change one little move, okay? And which is fine. So we got to this point here, 1 over tan. So I'm going to go down to the bottom and just work from that point, okay? And then we can kind of organize at the end. 1 over tangent theta times cos theta, okay? And if you remember that rule, tan theta is equal to sine theta over cos theta. Well, we can manipulate this, is it a quotient identity? Yeah, we can manipulate this. Sine theta is actually equal to tan theta times cos theta, okay, is equal to sine. So in other words, we can replace this blue line. We can replace all of that with just sine theta, okay? So we go about doing that. We're now at, say it's equal to the right, 1 over just sine theta. And we know that from here, 1 over sine is actually equal to cosecant theta. So we get our cosecant theta in the end. So that one little step we did have to do a skip. We couldn't just flip, but we could manipulate it. Like this right side still gave us a bunch of important information. So it still kind of looks messy. So it might be best if we put it all into one step here. Okay. So we started with our left side. Oops. Let's use a real color here. We started with the left side, and it originally said cotangent theta times secant, I think, yes. Secant theta. Okay. We inverted both of them. Okay. So all we're going to do is continuously look up to our information and organize it. So again, it's fine that we worked on both sides. We just have to organize it nicely. We then went to 1 over tan theta times 1 over cos theta. Okay. Still all equal to the right side. We multiplied the two. 1 over tan theta times cos theta. Okay. We figured out that cos times tan is actually the same as sine, so we can just replace it with sine theta. And then we know 1 over sine theta is equal to cosecant theta. And lo and behold, we've now only used the left side, even though when we started this, well, we didn't really know where to go, so we had to use some information on the right. Okay. So though they may tell you don't work on both sides, it's fine to do it. Just in the very end, when you supply your answer, just kind of bring that information down to make it a much longer looking row. Does that